We said in the previous video that different languages have different concepts. The question for this talk is, does the language you speak influence the way you think? Precisely this question was addressed by Benjamin Lee Whorf, who formulated the linguistic relativity principle. According to Whorf, the linguistic relativity principle means that users of markedly different grammars are pointed by their grammars toward different types of observations and different evaluations of externally similar acts of observation, and hence are not equivalent as observers, but must arrive at somewhat different views of the world. Whorf makes it clear that by grammar he means just language, that is, both lexical and grammatical concepts. The linguistic relativity principle is a verifiable scientific hypothesis. Let us unpack what Whorf actually says. We know that different languages categorize the reality differently. This means that speakers of different languages learn to pay attention to different aspects of reality that their languages obligatorily express. This, in turn, allows us to hypothesize that speakers of different languages will respond differently to specific experimental tasks, including non-verbal tasks. In this presentation, we will look at a few empirical studies examining how different languages affect people's minds and brains. Let us start with color. Does the language you speak affect your color perception? That is, does the language you speak affect how your brain sees the different colors? Color is a physical spectrum, and different languages divide this spectrum into different color categories somewhat differently. Color is also relatively easy to study because different systems have been devised to precisely describe all the different shades, mainly for industrial purposes. This makes the researcher's task easier because a study conducted in one laboratory can be replicated by another team in a different laboratory. The first study we are going to have a look at compares speakers of Greek to monolingual English speakers. Greek has two different colors, ble and galatio, where English has only one, blue. This means that while looking at this picture, a speaker of Greek sees two different colors, where speakers of English would only see different shades of blue. The study in question was carried out using EEG. In the picture, you can see a study participant wearing a cap with electrodes to measure their brain activity while doing the task. The picture below shows what happened in the study. The participants looked at a computer screen where they saw a series of circles that were all of the same color, either blue or green. These circles are called standards. Once in a while, the color changed either from light to dark or from dark to light. These circles, where the color changes, are called deviants. But the study participants were not told that the study was about color at all. Their only task was to press a button when they saw a square. The figures show the study results in native English and native Greek participants. We are going to compare brain activity in these two groups of participants in a very specific time window at around 200 milliseconds since stimulus presentation. This area is indicated in the pictures by a grey box. The dotted lines show brain response to standard circles, and the solid line shows brain response to the deviants. If you look at the English native speakers, you can see that there is a difference in how the brain responds to the standards and to the deviants. The response to the deviants is stronger. This is normal, and it indicates that our brains are sensitive to change in the visual field. Something changes and your brain registers it instantly. What is more, the English brains respond identically to green and blue. You can see that the green and blue lines go together, as the only change the participants see is either from light to dark or from dark to light. But it is always change within the same color that they see. But if you look at the Greek participants, the results are different. When they look at the standards, it does not matter if they are blue or green. But when a deviant appears, the Greek brains respond more strongly to change in blue than to change in green. Why? Because when light green changes to dark green, it is still green, a different shade of the same color. But when light blue changes to dark blue, the Greek brains see a different color, not just a different shade of the same color. All this happens at 200 milliseconds since stimulus presentation, which is actually a fifth of a second, literally a split second, and depending on what language you speak, your brain makes sense of what you're looking at, even if you're not consciously aware of it yet. Okay, so the brain distinguishes the different colors that your language can name, which means that people speaking different languages will see the colors somewhat differently. But we can all still see the different shades of the same color. How about that? A different study was conducted with speakers of Mandarin Chinese to see if the two hemispheres of the brain would respond to change in color in the same participants. Panel A shows the 4 colors that were selected for the study. 2 green colors and 2 blue colors. You can see in the picture that green 2 is quite similar to blue 1. Perhaps a different language would categorize them as different shades of the same color, but not Mandarin Chinese. The dotted line here shows the boundary between green and blue in Mandarin Chinese. Panel B shows the experimental design. The grey rectangles here are the different computer screens the participants see one after another. The participants, again, are told nothing about colours. They are told to press a button when they see a circle in the middle of the screen. The circle is the target. Then we have standards, as in the previous experiment, when nothing changes from one screen to another. The deviants are when one of the squares changes, and the change can be either on the left, in the left visual field, or on the right, that is in the right visual field. Now, the trick is that what we see in our left visual field goes to the right hemisphere of the brain, and what we see in the right visual field goes to the left hemisphere of the brain. In this way, we can find out if there is any difference in how the 2 hemispheres of the brain process what we are looking at. Now, we are looking again at what happens at about 200 milliseconds. First, in panel A, we are going to look at what happens in the left hemisphere. The green line shows the brain's response to standards. The blue line shows the response to between category variants. That is when green changes into blue or blue changes into green. And the red line shows a response to within category variants, which means that the change is to a different shade of the same color. Now, what the left hemisphere results show us is a stronger response to between category variants. If you look at the picture on the right, you can see that now the 2 lines are up, the blue and the red one. So this means that the brain response is equally strong to both change in color and change to a different shade of the same color. All this means that the linguistic relativity effect can be observed in the left hemisphere of the brain, but not in the right hemisphere. In other words, the language you speak will influence how the left hemisphere of the brain responds to color, but the right hemisphere is not sensitive to language and linguistic categories. It registers all the changes in the environment, independently of whether they were encoded in language or not. The last experiment we are going to look at shows us what happens in the brain when we learn new concepts in another language. This is an artificial language learning experiment in which the researchers invented new non-existing objects and invented different names for them, and then asked the participants to learn the new words. Sometimes the participants would be just shown the pictures and asked to memorize the words for them. Sometimes they would also receive some information about what these objects are used for. Then, like in the previous experiment, the participants were shown pairs of objects belonging to the same or to different categories to see how their brains would respond to them. The results of the study confirm the findings of the two studies discussed previously, finding an additional effect at 100 milliseconds. So the left hemisphere of the brain recognizes the newly learned categories at 100 milliseconds already, which is at the moment the shortest time interval at which we can measure brain activity. This means that new categories can be learned in a new language, and the brain will learn to recognize them effectively. To sum up, linguistic categories of the native language affect how the brain responds to the environment, and new categories of another language can be learned effectively, and the brain will be able to detect them automatically.